Hello everyone, and welcome back to our solution on the 2025 West African Senior School Certificate Examination. In the previous videos, we considered the solutions to question 1 and 2, and here we'll be taking on the third question, where we are told that a company installs solar panel in its premises to reduce its electricity costs, and the monthly savings on electricity in dollars is modeled by the relation S equals to 200 plus 50x minus 2x squared. X is said to be the number of months after installation. So we're told to find the time, perhaps the number of months when the savings on the electricity will stop increasing, and also the maximum savings that will have been achieved at this time. So this question is can be approached in two ways. Now, the first thing we'll have to understand is what are they trying to say here? Now, instead of using the electricity from the grid, the company decided to install solar panel. So the moment they install a solar panel, definitely they will not have to pay for electricity again, at least, or they will say the amount of money they pay on electricity will be reduced. So, meaning the amount of money they are supposed to spend on electricity will be saved. That is where this relation comes from. So the savings they are having in a particular month over a number of months is molded using this relation. So from the relation we have here now, how they come about this relation, we are not really concerned about this. So you can see this is a quadratic relation. Why do I say this is a quadratic relation? You can see the highest power of x you have here is 2. So this is a second order equation. So this is a quadratic expression. And how do we find when this relation will stop increasing? Now, the first thing you have to notice is that if you are familiar with the quadratic equation very well, your quadratic equation can be in two forms. Either it is of this form, ax squared plus bx plus c equals 0, and you can also have this a to be negative minus ax squared plus bx plus c equals 0. So if you are very conversant with quadratic graphs very well, so you notice that whenever you have the coefficient of your x squared to be a positive number, like in this first case, your graph is going to be a graph like this. So it's going to have a minimum value. It's going to be a graph that is initially falling, then it starts rising. Then if the coefficient of x squared happens to be a negative number, your graph is going to be this way. So if I'm given an equation like y equals to 3x squared plus x squared plus 5x minus 6, and I'm to plot the graph of this equation, without plotting it, definitely I know my graph is going to look this way. And if it is minus 3x, that's when the coefficient of x squared is 0, it's negative, then I know my graph is going to be this way. Now from our model here, the coefficient of x squared is negative, so that is why you are told that when will the the savings stop rising. So for a graph that has the coefficient of x squared to be negative, so you notice that the graph was initially rising. So when you are going from left to right, the graph was rising, and at some point it stopped rising at this point. So we'll call these points where this graph stopped rising, we'll call this a stationary point, or we'll call it turning point. Stationary points, or you call this a turning point, to turning point. So this is a topic under application of differentiation. So the points where the graph, a parabola or any curve starts rising, stop rising or stop falling, is called a stationary point or turning point, and that is what we have to find here. So what this question is actually saying, that this model is a parabola, so it is going to be like this graph I have drawn here, this one in particular. I said it is going to be like this because the coefficient of x squared is negative. So I said this is for when the coefficient of x squared is positive, while this is for when it is negative. And since here we have the coefficient of x squared to be minus 2, so we know it is going to be a graph like this. So if our graph is this way, if the model is this way, at what time will the savings on electricity stop increasing? This is what we are told to find. So if you have to draw this on a graph, the model on a graph, it is going to be something like this, where this is going to be the S axis. I say S here because that is what they put here. If you notice, they no use Y. Y is going to be the X axis. So it is at this point the savings was increasing this way. Then when it gets to this point, it stopped increasing. So there are many reasons it could stop increasing, then it starts decreasing again. One of the reasons could be that they have to start maintaining the solar panel. So in that case, they have to get some money to maintain the what's it called, the solar panel. Maybe the batteries become become worn out and they have to replace this. So definitely the savings will start reducing. So we want to know the month, that's the value of X where this occurs. We want to know the value of X where the parabola stop increasing. That's when the savings stop increasing. Now, how do we do this? So how do we investigate the stationary points of a curve? So what you just do is, the curve we are given here is S equals to 200 plus 50x minus 2x squared. So try to note this. For a curve, y equals to ax squared plus bx plus c. The stationary points or turning points occurs at the point where the y, the x is equals to 0. So stationary points occurs at the points for any curve. It could be a parabola or a cubic graph. The what's it called? The turning point occurs at the point where the y, the x is 0. So our turning points here, that means the point where the savings stop increasing, will also occur at the point where the s, we don't have y here, what we have is s. So we're going to have the s, the x. So it is going to occur at the point where our ds, the x is equal to 0. So let's find the s, the x first. You know how you differentiate. So yeah, you might have a little problem with this if you are not familiar with differentiation before. But for this question, I'm still going to use another method, which has nothing to do with differentiation. So you can just stay with me. If you don't know differentiation, you still have a method that will work for you. So when you differentiate 200, 200 is a constant. Why? Because it doesn't have x. So when you differentiate the constant, it becomes 0. When you differentiate 50x, for those that are familiar with differentiation, you know this is 50x raised to power 1. By the time 1 comes here, it multiplies 50. You are going to have 50x raised to power 1 minus 1, which is going to be 50x raised to power 0. And you remember x raised to power 0 is going to be 1. Any non-zero number raised to power 0 is 1. So this becomes 50. Then when you differentiate minus 2x squared, 2 will step down to multiply this minus 2. And that will give you minus 4x. Then you remove 1 from this power. The same way we remove 1 from here. So give 0. Remove 1 from here. That is just the normal way of differentiating. You're going to have 4x raised to power 1. I may not write the 1. So this is my ds, the x. So this parabola has this gradients. So then I said the points where the savings will stop increasing will be the point at which, so the savings will stop increasing at the s, the x equals 0. So as we mentioned earlier, the parabola will stop rising at the point where the s, the x is equal to 0. And remember, we already found that the s, the x to be 50 minus 4x. So the savings will stop increasing at the point where the s, the x, that's 50 minus 4x is equal to 0. So I'm making use of this fact that our parabola will stop increasing at the point where the s, the x is equal to 0. And since we found the x to be 50 minus 4x, so 50 minus 4x is going to be equal to 0. And all we have to do here is to find x. So take minus 4x to this side, that means to have 50 equals to 4x. And x is going to be equals to 50 over 4, which is going to give you, that should be 12.5. So therefore, the savings, remember you've been told in the question that x is the number of months. So the saving will stop increasing after 12.5 months. That's the value of your x. So you can just say, so therefore the savings will stop increasing after, just manage this my handwriting, 12.5 months. So that is what the first question requires you to do. Then remember I told you that we can also solve this question using another method that does not have to do with differentiation. This particular first question. And how do we do that? Now, for the parabola it refers to here, we will call these points, for a parabola, not differentiation this time, we'll call this point a vertex. Vertex. This one is also called a vertex. And since this the curve, we've established that it is a parabola, it is a quadratic graph. So the vertex of a parabola is usually calculated using the formula, the x value to be precise, s equals to minus b over 2a. So for this parabola now, if you are told that what will be the x value at this point, it is going to be minus b over 2a. You know where we got b from? B is the coefficient of x. While a is what? Coefficient of x squared. So you can also make use of this formula to get the value of x. And how do you do that? So this is an alternative method. So, or you say, now from this equation you are given here, if I want to write this equation, I can write it as s equals to, I want the x squared to come first, just to avoid mistake. I'm going to have minus 2x squared coming first, minus 2x squared. This is not compulsory anyway. Then I want 50x to follow, plus 50x. Then the last is 200, which is plus 200, plus 200. So what I can deduce from here is that comparing with the general equation of the general form of the quadratic equation, which is ax squared plus bx plus c, just the same way you only solve your quadratic equation using the quadratic formula. Now your a is the coefficient of x squared, which is 200 minus 2 in this case. So I can say my a is equals to minus 2. B is the coefficient of x, which in this case is plus 50. So b is 50. I don't need c, but I can write it as c is also the last one that does not have x. It has x to power 0, but we don't write it, which is 200. Fine. Now from here now, your vertex of a parabola, vertex of a parabola occurs at x equals to minus b over 2a. So x is then going to be equals to minus what's our b? 50 over 2 times a, that's 2 times, what is our a? A is minus 2, 2 times minus 2. So this is going to give us minus 50 over 2 times minus 2 is going to give minus 4. Minus can cancel minus. So this is going to be, sorry, this is 4, not 40. That's 2 times minus 2, 4. So 50 over 4 is going to give us 12.5, just as we have here. So your s is also 12.5. So it is in differentiation I said we call these points, we call this a turning point or a stationary point. But for a parabola, we call it a vertex. So I said the vertex of a parabola occurs at x equals to minus b over 2a. So I feel this seems to be a bit shorter and more straightforward, but you can use any method you like. Now that we've known when the what's it called, the months when the savings will peak, that means when it is going to reach its maximum value. So this point is just 12.5. So the second question is find the maximum savings. What they're just asking us to find is that what is going to be the corresponding value of S at this point. At the point where X is 12.5, what is going to be the corresponding value of X? That's X maximum. That is the second question. So this we are done with first question. Now the second question is that the maximum savings is going to be what? So the maximum savings, say we call that S max, will occur at the turning point, the vertex, which we already got to be S equals to 12.5, will occur at X equals to 12.5. So this is just like saying find the value of S when X is 12.5. And how will you do that? Just put X equals to 12.5 into this relation. You want to find S, you know X to be 12.5. So your S maximum, that's the maximum savings, is going to be 200. That's the first thing you have here, plus 5. Instead of this X, you're going to have plus 50 into bracket. X is 12.5. 12.5. Then minus 2x squared. That will be minus 2 into bracket x squared. 12.5 squared. So this the maximum savings is going to be 200. 50 times 12.5 is going to give you plus what does that give? 62.5. 62. I'm sorry, 625 rather. 625. Then minus 12.5 square is going to give you 156.25. Then times 2, that should be 312.5. So by the time you compute this, you're going to have your maximum savings to be 512.5 dollars. Remember, you are told that the savings is in dollars. So this is the maximum savings you can have from that model, and that maximum savings occurs at what month? Occurs as 12 and a half months. So after 12 and a half months, the company savings will start dropping again. So that is all the question requires you to do. Thank you for listening. I'll see you in the next question.